Hi, this is Mr. Gazelle. Thanks for joining me for this example. I want to talk a little bit about factoring and go through this example problem right here. It says to factor the expression negative 6x squared plus 15x plus 36. So there are lots of different ways that I could factor this, and you are certainly free to use whichever way makes the most sense to you. I'm going to show you my favorite way. So of course, factoring really means that I'm going to break this down into parts that are being multiplied together. A factor is something that's being multiplied by something else. So typically, I'm going to have some constant value multiplied by a binomial factor multiplied by another binomial factor. Binomials have two things added or subtracted. And at first this seems like a rather complicated process because there are really 5 different constants, 5 different numbers that I'm going to have to find. Let's just call those numbers A, B, C, D, and E. I'm going to have some constant value out front. Perhaps it might be 1, but it could be some other number. I'm then going to have another constant value here in front of the x. And then that's going to be added to a third constant value. And then this binomial is going to be made up of a fourth constant value times x plus a fifth constant value. So figuring out all 5 of those values in our heads can at first seem a little bit intimidating, but there are different processes that you can use to make it a lot simpler, and I'm going to show you one of those. So the way that I like to do it is to look at these 3 terms, and first of all, figure out if there is any greatest common factor that I can factor out. So the first step is to factor out any greatest common factor. And if that first term, the x squared term, is negative, I'm going to factor out a negative greatest common factor. So in this case it is. So I'm going to factor out the largest number, and I'm going to factor out a negative number in this case. It goes into negative 6, 15, and 36. And that number is negative 3. Now that I've factored out the negative 3, what I'm going to have left is a trinomial. In this case, it's going to be 2x squared minus 5x minus 12. Notice that since I factored out a negative greatest common factor, negative 3, the leading coefficient here is going to be positive, which is going to make it easier to factor in the long run. So now I want to figure out what my 2 binomials have to be so that when I multiply them together, I get 2x squared minus 5x minus 12. Now, if I think about that a little bit, I'm looking for some binomial multiplied by some other binomial, such that the first 2 terms, if I'm thinking about FOIL, the first 2 terms, when I multiply them together, I end up with 2x squared. And the last 2 terms, when I multiply them together, I end up with negative 12. And then the outside and the inside terms add together to give me this negative 5x. So I'm really looking for 2 terms that add together to give me negative 5x. Now those 2 terms are also going to have to multiply together to give me whatever 2x squared times negative 12 is. In this case, negative 24x squared. So I'm really looking for 2 terms that multiply together to negative 24x squared and add together to negative 5x. And in this case, those two numbers are going to be negative 8x and positive 3x, because negative 8x times 3x is negative 24x squared, and negative 8x plus 3x is negative 5x. Negative 8x and 3x. So now what I'm going to do is I'm going to look for the greatest common factor of these two, of these two, of these two, and of these two. So the greatest common factor of 2x squared and 3x is just x. The greatest common factor of negative 8x and negative 12 is negative 4. Again, if the first term here is negative, I'm going to factor out a negative factor. The first term here is positive, the top one is positive, so I'm just going to factor out a 2x. And the greatest common factor here would be a positive 3. Now I can see if I FOIL this out, if I multiply these two binomials together, x times 2x is 2x squared, x times 3 is 3x, 2x times negative 4 is negative 8x, and negative 4 times 3 is negative 12. So the factored version of this quadratic expression is 1x minus 4 times 2x plus 3. And then I don't want to forget that at the very beginning here, I factored out a negative 3. So I'm going to put that negative 3 in front. Final answer, negative 3 times x minus 4 times 2x plus 3. This is sometimes called the box and diamond method, and it can be used to factor any quadratic trinomial as long as it is factorable. In other words, as long as there actually exists 5 integers, a, b, c, d, and e, such that when I multiply them together, I actually get this quadratic trinomial. In other words, if it is factorable, I can use this method to factor it. I should point out that what I really did here with this box is something called factoring by grouping. Because once I figured out that my two middle terms have to be negative 8x and 3x in order to factor this quadratic trinomial, I really could just rewrite it as 2x squared. And then instead of writing minus 5x, I'll write minus 8x and plus 3x minus 12. And then if I group these together, which is really what I was doing in my box anyway, I can see that here I can factor out a 2x, and here I can factor out a positive 3. And the x minus 4 ended up being my row, and the 2x plus 3 ended up being across the top, my columns, and I can now group those together, 2x plus 3 times x minus 4. So factoring by grouping or using the box method are really equivalent to the same thing. Thanks for working through this problem with me.